Hello everyone and welcome to this, my video on simultaneous equations using elimination. Oh, so exciting. Yes? No, not really. No, it is. My name's Darren from Maths Guru. Thank you very much for joining me. If you haven't already done so, massive favour to ask. A little bit needy. If you can subscribe to my YouTube channel, that will be great. Why? No one watches maths videos. Everyone wants to watch people eating and cats and strange things like that. So every time someone subscribes, at the end of the day, when YouTube just let me know, I get a little bit excited, really. If that number goes above 3, I sort of run around like a lunatic and go, yay, 3 people that aren't my mother have subscribed. So if you can do that, that would be great. And as I've said, I'm from Maths Guru. Yep. Basically, it's my little corner of the interweb. If you head over there, these videos are all there, all structured for you with downloadable notes. Yes, what I write on behind me, you can download and write all over. And maybe that's a good idea. There's exam questions and so much more. Right, what am I going to get on with? Well, normally I would read through this stuff, but you can pause the video if you want to. It's basically building on the video I have, funnily enough, just recorded, which deals with solving simultaneous equations by, yes, in this situation, I did it with, what did I do? Substitution. Yes, I did it by substitution. It says there by graphical methods. If you know anything about simultaneous equations, and I think I've got a video on this coming up. Simultaneous equations are just really 2 straight lines that hopefully cross in a particular point, 1 point. And that 1 point is called a solution. So if we look at this graph here, then what have I got? I've got 2 lines, 1 blue and 1 red. Which basically seem to cross at that point there, and that's a solution. So whenever you're doing simultaneous equations, you're trying to find where 2 straight lines hopefully cross in one place. And there are lots of ways that straight lines can cross or not cross. As I say, we're going to do elimination now. There is another way we can do this called matrices, and for those of you in Australia, when you get to a VCE, we can teach you that. Maybe if you do it in the UK and other places in sort of A-levels and what have you, that will be good as well. But my previous video looked at, as I said there, substitution. Now let's look at elimination. A lot of people find elimination quite challenging, but again, it's just built on rules. And if you write the rules down and you sort of practice them over and over again, and you are going to make mistakes. But the way you're going to make mistakes is, generally speaking, with the negative signs. They are the things that trip you up over and over and over again. So if you look for the mistakes you're about to make, the chances are you won't make them. But again, algebra is full of tricks, and being able to identify here that those 2 there are exactly the same equation is one of those tricks we can tend to throw at you. How is it the same equation? Because I've taken the top equation and simply multiplied absolutely every term by 2. And that makes it the same equation. If I had, for example, led this value here to be, I don't know, 11, then I would know that those 2 were parallel. But again, big jump into another video. Right, I feel like I'm waffling. Should we get on with this? Let's look at some examples. Now, the rules are pretty much this. To be able to eliminate, you are looking for columns. You are looking for x columns or y columns to have the same coefficient. You're going to say, what? The number in front of them have got to be the same. Doesn't matter what the sign is. I don't care if it's a plus or a minus. It's got to be the same. So if I look at this now, look at my x column. I've got, what number is in front of that x? Well, you're going to say there isn't a number, and I'm going to say, yes, there is. It's a 1. What number's in front of that one there? Again, don't worry about the sign. I'm not interested about the sign, but there's a 1. Let's look at these 2 columns. What's in front of the y? This one here. Well, let's say it's a 2. And what's in front of that y? It's a 5. Again, I don't really care about the signs at the moment. The first rule is to get the numbers in front of either the x's or the y's to be the same. Well, hold on a moment. The numbers in front of the x's are the same. Awesome. So what I tend to do now is I write them out again. All right, this is a fairly pointless step until later on, but x minus 2y equals 1 and negative x plus 5y equals 2. Now, I would normally highlight them to say, hey, I know these are the same. And it's a visual cue because the next rule says, look at the signs in front of the numbers. So of the column that's the same, now look at the signs. And I can see here that I've got a positive and I've got a negative. Now let's go back to the rules we had before. Remember, if we had a positive and a negative and a negative, it becomes positive. If there's a negative and a positive or a positive and a negative, they become negative, yeah? Well, for this one step, you change that. You do the opposite. So because I've got a positive and a negative, I would normally subtract, change those to a minus sign. What I'm actually going to do is I'm now going to add the two equations together. Now, by what I mean that is I'm going to add the columns together. Now, guys, if this is already sounding confusing, I am so sorry. I don't make the rules. I just try and teach them. Yeah? It is something that comes with practice, and it is literally those two rules. Make the numbers in one of the columns the same, look at the signs, and do the opposite. And then everything else sort of makes sense. So what I'm now going to do is I'm going to do each column. So I've got positive x plus negative x. So if I did x plus minus x, now in this situation the rule stays what we would expect. Plus and a minus becomes a minus. I've got x minus x. It actually disappears. So that's why it's called elimination, because we want one of the columns to eliminate. So let's look at the next column. I've got minus 2y's plus 5y's. Well, a positive and a positive is a positive. So minus 2y plus 5y, and what I do is I write that as 3y. Then I do my next column. 1 plus 2 gives me 3. And lo and behold, I've eliminated my x's, which basically gives me something now I can solve. I've got 3y equals 3. So if I divide both sides by 3, I get y is equal to 1. Ka-ching, that's it, I'm finished. No, because if you remember the previous video, oh yeah, you didn't watch the previous video, it's on mathsguru.com. If you remember the previous video, it's not solved until we've got an x value and a y value. Now, substitution, it was so easy now. But let's go and say, well, I've got y equals 1. That's what I've got to do. I've got to use one of my equations, one of my original equations, to help me find my x value. But which one am I going to use? To be honest with you, it doesn't really matter. You try and use the one that looks a bit more simple, but in this situation, it doesn't make any difference whatsoever. So what I'm going to do is I'm going to write down that x minus 2y is equal to 1. All right, so all I've done is written down my first equation, because I know that my y value is 1, so I can substitute that into there. So I've got x minus 2 times 1 equals 1. X minus 2 equals 1. X must equal 3. And there we go. I've got my solution of 3, 1. Again, there's lots of teachers going, what are you doing out there? Now, what I would suggest you do is you now check, right? Because you need to check that this works in the second equation. We only used the first equation, didn't we, to get this? What if we've made a silly mistake? Well, we're not going to know until we now check with our second equation. What I mean by that is I do minus x plus 5y. Right, well, what is the value of x? It's 3. So minus x must be minus 3. All I'm doing is now substituting my x value into my equation, and I'm going to substitute my y value into that there, or my expression, I should say. 5 times 1 is going to give me 5. What is minus 3 plus 5? It's 2. Was I expecting 2? I should cocoa, because if minus x plus 5 equals 2, then I'm correct. So that check is just an additional stage, because sometimes these questions are worth 3 or 4 marks. If you don't do the check, you could lose all 3 or 4 of those marks.